Hello, this is Herrera bin Sohail for ISE Show TV. I'm here with Jon McLoone from Wolfram. John, let's talk about AI. It's all the buzz. There's a lot of positivity around it. You're speaking on the topic at ISE as well. But you seem to be preaching a little bit of caution. Why is that?
I bring the dose of skepticism to this event. I think. I should start by saying I think it's amazing.
Yep.
The LLM technology that's driving this wave of generative AI can truly do things that we've struggled with for decades, and it's a great extra component. But it's not a solution to everything in its own right. It has some fundamental problems, and at the core of that is that it can't be trusted. It can't be trusted, particularly with things that are factual, because it is just designed in a way that makes up outright lies sometimes, but it sort of fills in its lack of knowledge in a very confident way, very convincing, but anything that you rely on for as a statement of fact has to come from outside of this technology.
Yeah, it's very interesting that you say that, because I think everyone's catching on to the term of hallucination, right? AI hallucinates, and there is this burgeoning conversation around the reliability of it, which you've just pointed out. You would know because you've been working at Wolfram for so long. But how do we address these shortcomings? How do we spot them? What is your advice?
Yeah, hallucination is a nice euphemism, isn't it, for something that can be lying to you. It all stems from the way that they work, that they're all about trying to produce language models. They don't actually really have knowledge or understanding in a precise way, and so they can be very convincing. But it's what they do is actually the kind of opposite of what we've been doing at Wolfram for a long time. So we've spent 35 years building technology for deliberate computation.
Yep.
So using things like equations or time series analysis in finance or engineering calculations, very concrete, precise things where there's solid theoretical basis. And I always think we're the slightly sort of nerdy Aspergic side of the human nature, and the LLMs are the poetic and confident side. And what you need to do for a good solution is to bring both parts together. So the LLM is a great component. It can take the kinds of things that we do that are sometimes hard to understand and contextualize them, explain them. It can mesh the real world to computation. And what we do is the opposite. We can do the hard maths, the getting reliable things, but we're not very fluent and we can't plug in easily into people through human interfaces. So the answer is you've got to figure out how to build it as a component. You can make a great interface layer if you like chat. It can make a great data layer if it's about fetching unstructured data and giving it structure. But then you need layers that do things that now seem old-fashioned, like using databases to look up data, or using models and digital twins to compute things that aren't knowable in advance. But you've got to bring those things together to get the reliability.
Yeah, it's very interesting, right? Like, it's almost as like the promise of AI, which is this thing thinks better, faster, quicker for you, is the thing that everyone wants to get to, but getting there's not that easy, right? Like you just pointed out, we've got someone that can speak now, and we've got someone that can do that hard mathematics kind of processing and algorithming within a certain data set, but joining those two still needs to happen.
And the joining is a challenge, because there's a kind of new world of software engineering that people are getting to grips with. That in the world I come from, you run some code, it works. You run it again, you'll get the same answer. Once you've proven it works for a bunch of examples, it's reliable. Whereas the LLM technology, in order to appear fluent and human-like, it's different every time. And just because it works well on one thing doesn't mean it will do something crazy the next day. And in a way, it's exaggerated the classic sort of 80-20 problem of 80% of the work is the last 20% of the solution, but it's way so more, because we see a lot of projects where it's so amazing for that first proof of concept that everyone patting themselves on the back and saying, in another week or two we'll have the thing in production. And then when they're trying to get that last bit of making it safe and reliable, then they just never quite get there. And that's where most AI projects at the moment are failing, is getting over that reliability threshold.
You reckon AI can build that bridge itself? Because we've got Claude out there programming, we've got Moltbook, Molthub, where the agents are talking together. Is that a possibility?
Okay, you've got two things, slightly different things up there. So there's the whole sort of reasoning model approach. And I think there's now been enough study that reasoning models sort of improve simple problems, and then they reach some level at which they have a catastrophic loss of reliability, and you're sort of pushing a problem slightly further away, but sharpening it in a way. Because in the end, they still don't understand anything. They're still building a pattern of words that sound like the right answer. That's basically their job. So that's one approach. Another approach going on at the moment, of course, is ingesting things like search.
Yep.
And search really has improved
Yep.
LLMs because there's an external source of facts. But in the end, search can only retrieve known facts. So if you're ever, same with, Google something, if somebody's answered the question, you find a page, you get an answer, but you can never get anything that is not yet known. So arithmetic's a perfect example that we learn the 10 times table as facts.
Yes.
But we don't learn the 372 times table because we have a method for working out things that have never been asked before. So in theory, you could ask me any multiplication, I can tell you the answer, even if it's never been done before. And so the world is full of things like that where there are not yet known facts that require models and digital twins to do simulations. And then there's this other thing you mentioned, which is coding. And coding is kind of an interesting one because they're actually pretty good at coding because computer languages are a lot like, they're more formal, but they're basically more like human languages. So since they're built as language models, they're actually very good at coding. But there's still a challenge there that, again, up to a point, if I ask for write me an HTML page with some CSS, do a perfect job in one shot, and people whose job was doing low-level coding, that's going to be a real challenge for them to justify themselves. But above that level of complexity, all of the things that make code maintainable, they still apply because the LLMs can't do that at that level. And if you believe you're never going to touch the code again, it doesn't matter if you don't know how it works. But we're a long way from that. So the danger is that ill-disciplined use of LLMs in programming will create very verbose large code bases that no one understands. It's bad enough when humans have done
exactly.
it, but,
you start doing away with documentation, and then all of a sudden a human has to look at just raw code.
Exactly. So at some point you have to get involved as a human, and if the LLM has been kind of ill-disciplined because it's relentless, but not very good at being, boiling it down with true intelligence, then you can end up with a real kind of liability of code bases.
Last question from my side. Businesses, leaders, right? Like they find themselves in this interesting spot where there's this fear of being left behind if you don't have an AI strategy, or if you're not looking at AI and you're not adopting it. But then we've just talked a lot about the shortcomings, the things that you need to be wary of, the ethics, the reliability. What would your advice be to businesses and leaders on how they should be approaching AI and what they should be doing?
Well, I mean, this is a pretty broad thing. It's like saying, well, the internet came along, how does that change business? And I think one of the things is that we don't really know the big implications yet. Just like the internet was, oh great, I can put a document on a web page. What's that? Well, let's put an advert on a web page. Really obvious things, and the less obvious things like social media or Uber take time to emerge. I think we're in that obvious stage at the moment. We got chat. Let's put a chatbot on our site. And we got meeting notes. Let's summarize them. And those really low-hanging fruit. So I think one thing is pursue some of that low-hanging fruit, and my first tip is look for jobs that can only be done by humans, but are not really using a human. We've all had jobs like that where you're typing things up from one place to another, and you're triaging emails to the right person, and it really doesn't take human intelligence to achieve that. So those kinds of fuzzy jobs, but really brainless jobs, they're really obvious low-hanging fruit. But beyond that, I would discourage the let's cost cuts and say we don't need programmers anymore. We don't need salespeople, marketing people. We can just churn out AI slop and replace them, because I think the key thing is to focus on the value that your talented people have and ask, how can I make them more efficient? How can I give them the knowledge on demand that they need to do their jobs better? How can I help them to get the information from one place to another better, but not get rid of talented people, because the I is an overstatement of AI. It's still a machine. It's still doing very impressive, but kind of algorithmic things. And I'm not a believer in the kind of general AI being just around the corner. I think humans have a place for quite a long time yet.
Jon, thank you so much for your time.
It's been a pleasure. Thanks.